Hello guys, welcome to another video of problem reading series of GFG and LeetCode problem reading. So I hope you did try out the problem on your own. And if not, first try out the problem on your own and then come to this video if you didn't get any solution. So let's dive into the problems. So the first problem is maximum nesting depth of the parent list. Now the problem statement is we are given a VPS if it meets one of the following. It is an empty string or a single character not equal to uh, open bracket and close bracket. Then it can be written as A concatenated B, and it can be written as single character A with open and close bracket, where E is a VPS. Now, to summarize this all these problem statements, we will be given a VPS, and we have to find out the nesting depth of VPS. Now, what a nesting depth of a VPS is? Suppose so. Let's take this example. So suppose there are empty and so there it is an empty string without any numbers or signs. It is just a string with open and close bracket. So as you can see in this open bracket have a closing bracket here. So this nesting depth is 1 because inside it there are no open and close bracket. Now in for this you can see the nesting depth is 2 because for this open bracket there's inside this open bracket there's another open bracket. So the nesting depth of this string is 2. Now as you can see in this example we are given this string. For this open bracket, there's another inside it. There's another open bracket. Then it closes it here. So the nesting depth is 2 here. Now inside this open bracket, there's another open bracket. Inside this open bracket, there's another open bracket. So and then it closes here. So the nesting depth of this string is 2. Sorry, nesting depth is 3. And then it closes here and then it closes here. So the nesting depth of this whole string is 3. Now for this example, the nesting depth of this is 1 because inside this open and close bracket there is no open and close bracket. For this is 2 and for this it will be 3. So the constraint given to us are 1, it is between 1 and 100. So upon looking at this problem statement and this example, we can figure it out that we don't actually need these letters or this operation performing on them. We just have to see the open and close bracket or how deeper open bracket is going. So that's how we can find our answer. So because it is clearly said that we just have to find the depth. We have nothing to do with these numbers or this uh, symbols or letters given to us. So let's try solving this with an example. Yeah. Okay, so as you can see for this open bracket, so let's take it here. We have so this is our open bracket. Now inside it, upon it, so first we will iterate this whole string. Now inside it there is another open bracket. So let's take it open bracket, store it somewhere. Let's suppose it is a stack. Okay, so the this one here is our just consider this as a stack, and this is our top element for now. There's open bracket. Now we have found a close bracket. So from this, we could figure it out that there are total two open brackets in the stack because the length of the stack now will be 2. Now, as we have two open brackets, then, and we are sure that there is another close bracket that will definitely close this this first character. So upon taking the size of the stack, we will get our answer. Because this empty bracket will now remove this because for this open bracket we have found a closed bracket upon removing, so now that our result is 2. Let's take this here. Now we have found another open bracket, so the result now will be 2. It will not get updated because it is the same result. So upon taking this, now we are sure that there is another bracket which which will be closing this. There is another bracket which will be closing it, and this bracket open bracket is inside of it because the total size of the stack is 2. Because there are total two open brackets. Now inside it there's another open bracket. So let's take it in a stack. Now we have a closing bracket for this. So as the size of the stack is 3, so our result will be updated to 3 as it is a maximum size till now. Now we did find a closed bracket here, so we will just remove it. Now upon iterating it, we did find another closed bracket, so we will remove it. And finally we got our last closing bracket, so we will just remove it. And iterate till the whole string and find out our result as 3. So that's how you could figure out the solution. Now the thing that here is uh, we really don't need a stack. We do because as it is in the question, we just need to store somewhere the number of open brackets we have till now. So why not just take a variable which will store just the number of open brackets till we have. So let's take a variable as open brackets and is 0. Now if we find out the open bracket, we will increment it to 1. We find another open bracket, we will increment it to 2. Now we find out the closing bracket. So we will update our result as 2 and we will just decrement it to 1. Now we found another open bracket, then we found another open bracket, so we'll increment it to 3. Now as we got a closing bracket, we will decrement it to 2. Now we found another closing bracket, so we'll decrement it to 1, and then we found out another closing bracket, so we'll decrement it to 0. So that's how we could figure out the solution without using any of the extra space. So let's go towards code. So we have taken a variable open brackets which is initialized to 0. Now I have taken a character of string, array of character which will store all the character of this S and the result is 0. Now this for loop will iterate over all the character of S, and if we find out if we so let's take this algebra. If we found out open bracket, we will just do open brackets plus plus. Now, if str of I, if we found a closing bracket at a if we, at ith point, we will just update our result as open brackets, max of open brackets in result, and we decrement our open brackets, and then we will simply return our result. So the time complexity of this approach is big of n, as we are just iterating our whole string, and the space complexity is big of 1. Now let's go towards the GFG problem of the day. The problem is sum of all substring of a number. So another really good problem from GFG. Now given an integer s represented as a string, the task is to get the sum of all possible substring of a string. As the answer will be large, return answer as modulo of 10 is to 9 plus 7. Okay. So let's see this example. The given string is 1, 2, 3, 4, and all its substring are 1, 2, 3, 4, 2, 3, 1, 3, 4, 1, 2, 3, 4, 2, 3, 4, and 1, 1, 2, 3, 4. And upon summing up, we are getting a result as 1670. Now this example number 2 with SS421 and our output is 491. Now the constraint provided S is between 1 and 10 is to 5. So from the constraint we could figure out is that there will be no uh, means there we cannot find out the solution using any brute force approach. We have to find out a approach which is lesser than big of n square. What a big so big of n square approach will be just iterating. I will start from this character and j inside it there will be another for loop which will start from j equal to I to n, and upon getting all the substring, we will just convert the substring into a number and add it to our result, and that's how we could get our answer. So what a big of an approach will be. So it is the problem is mostly of a pattern-based approach where we have to find out, we have to write a solution of somewhere, and we have to figure out a solution. Okay, let's see this example. Uh, Let me remove this. So as a given example is 1, 2, 3, 4. Let's just take this. So what are all the substring of 1, 2, 3, 4? It will be 1, then 1, 2, and 1, 2, 3, 1, 2, 3, 4. These are all the substrings of our number 1, 2, 3, 4. So upon let's more further, so it will be 1. Now for this, the number of substrings, total number of substrings for this 1, 2 will be 1, 2, and 2. Total number of substrings for this will be 1, 2, 3, 2, 3, and 3. And for this it will be 1, 2, 3, 4, 2, 3, 4, 3, 4, and 4. Now let's just okay. So let's just take this example. So upon dividing it more, upon structuring it more further, what we could get is uh, so it is just 10 plus 0 plus 4. Uh, let's destructure it more further. It is 120 plus 20 plus 0 plus 3. Not 3, it will be 339. This will be 1230 plus 234 plus 34 and plus 0. Sorry, it will be 0 here plus 16. Now, uh, as you can see in this example, or as you can see in this uh, parts, we could figure it out that like what's the total of this? It will be 14. Okay, so as you can see in this, what we are getting from this total, because as you can see in this one two or this one is getting repeated here, or as you can see in this one two is getting repeated here, this two is getting repeated here. So we don't need to find out the whole substring and add it to get our answer. We could just use our previous answer and add and do a multiplication of that answer and add the total number of 3 or the total number of 4 that we totally need from the ith pointer, from the zeroth pointer till the ith pointer. So as you can see what this total is. So this total is 140 plus 9. So as we are getting this total as 140. What this total is? It will be 3 plus, it will be 146. Sorry, it will be 149 plus 60. So where we are getting this 14 from? So we are getting this 14 from our previous result. Where we are getting this 149. So this 149 is we are getting from our previous result. So it will be more of, so it is a dynamic programming approach where we get our solution from our previous answer and use this previous answer to get our current result. Don't consider this 0 for now, as we for as to add another character at the end we need to multiply it with 10. So this 14 is getting we are getting it from here. This 149 we are getting it from here. Let's add it to 149. So how to now? So now is how to get our current result. Because as we are using this 14, so at this it will be previous result which is 14 into 10, which will into 10 to get so that we can append our uh, 3 at, so we can append our 3 at the last position, plus the total number of 3. So what is the total number of 3? It will be uh, of length, it will be total number of 3 will be of size 3, because we need to consider it from 0 till I. So it will be 3 into 3, which is 9. For this it will be for this it will be 149 into 10 plus 16. So this will give a current result. Now upon adding all this result, this one, this 14, and then this 140, and then this 149, and this will be 1 5, and so it will be 1506. It will be 1506. So upon adding all this answer, we will get our final result. So that's how you could get a solution for this kind of problem where you could structure more and more and find out a solution from getting the previous result. Okay, so let's go to its code. So we have initialized a mod with 10 is to 9 plus 7. I I have taken a long year because this 1 in 9 plus 7 gives a value type as double. So I have converted it to long. Then I have just put the S. I have taken an array of character which will store all the S number or the S string. Then a prefix sum which will store our previous result till that current point I. Now I have taken the prefix sum of 0 of the first character. So this will just convert our first character to from character to number. And similarly for result, I've taken the variable result which will store our first result at point 0. Now I have taken now I will iterate till from I equal to 1 to the character length. This num store the character at the current position. Now this will be a important formula which will at prefix sum at the current ith pointer. It will store the prefix sum of it will store this previous result, which is prefix sum of I minus 1 into 10 mod modulus of mod. Then the current number into I plus 1. Why I plus 1? Because we need to find the total numbers now, or we need to multiply the total number from 0 to I, and we'll do a mod and then we'll do mod. So this will store our current result, and this result is used to store all the sum of the prefix, all the sum of the substrings of this string, and then finally we are returning our result. So the time complexity of the approach is big of n, and the space complexity of this approach is big of n. So so that this will be it for this video. I hope you did understood the solution, or I hope you did understood how we could approach this kind of problem. So if you enjoyed today's video, don't forget to like, share, and subscribe for more coding problems ahead. So until next time, happy coding, and may your algorithm always run efficiently.